अस्सलाम वालेकुम। क्या हाल है बेटा? आप लोगों के? उम्मीद है आप लोग खैरियत से होंगे। सो what we are doing tonight, I mean today, is I'm going to solve the test of section 4 chapter 1 simple magnetism and magnetic field, so that tomorrow we can start our class on time and we can completely focus on the class. So let me explain you each and every question, and maybe and I'll be posting timestamps in YouTube video, so that if you are having a difficulty in question number 1, you can click on question number 1 and you will be directed to that part of the video. Okay, beta? So let's start. First of all, it's a very important thing whenever you are having any test or any exam, you need to add or you need to write down the credentials of yours. Okay, so let's say I'm solving this test. Me myself is Muiz Ahmad Dawoodi. Class is CIET O levels batch A. Institute CIET, and let's start. So now we are going to explain question number 1. Which row describes the ease with which iron or steel can be magnetized or demagnetized? So आपने यहाँ पे देखा मैंने important चीजों को highlight कर दिया. So you can also do this. You cannot highlight in Cambridge examinations. You can always underline in Cambridge examinations. So this question is asking that you need to tell either iron is easy to magnetize or easy to demagnetize, or hard to magnetize or hard to demagnetize. So let's break this question down into several steps. For example, I'm talking about iron. So metal is iron, and iron is not difficult to magnetize, very easy to magnetize and easy to demagnetize. So option A can't be correct because this part goes wrong. While here iron easy to magnetize but difficult to demagnetize is wrong. Steel, difficult to magnetize and difficult to demagnetize. Both options are correct. So in our case, answer is option C. But let's go further ahead and discuss the last option, D, as well. Steel, not easy to magnetize, not easy to demagnetize. So in that way, we have our answer C. Okay, now move ahead. A student tries to magnetize a short steel rod. Which of these tests will show that he has been successful? He is about to, magnetize a steel rod, and which of the options are showing that he has magnetized the steel rod? So both ends of the permanent magnet attract the rod. No, not both ends. If the steel has become a magnetized material, at least one end will be repelling. One end of the permanent magnet repels the rod. So this part is correct. We have found our correct answer, but we'll also discuss. Some students were having questions and they sent me that, sir, how to attempt MCQs. So this is how you attempt MCQ. You have to read properly each and every question or the options. The rod picks small pieces of paper. Magnetic material does not have any relation with paper. Okay, so that is wrong. When freely suspended, the rod points in any direction. No, if magnet has become permanently magnetized, so let's say north of that magnet will be pointed towards the geographic north of the earth. Getting my point? So in that way, this is wrong. So we got B as an correct answer. Now, the 4 plotting compasses are placed near the bar magnet. You may ignore the effect of Earth's magnetic field. We don't need to include the Earth's magnetic field. It's not even the part of the syllabus. In which position does the compass appear like this? So for that, what I'm going to do, I am going to show you the pattern of the bar magnet, okay? Or the magnetic field pattern of a bar magnet. So the magnetic field pattern of a bar magnet is like, from north, one line goes like this like this, This goes like this. This goes like this. And this goes like this. Sorry. So we have to memorize the pattern of the bar magnet. So the pattern of the bar magnet is like this. Now I have told you earlier that for North Pole, the direction of the magnetic field line is always away, always outward from the North Pole. So here the direction will be this. So on this definition, only one option is appearing, and that is option number C. Because as you can see, the direction here is somehow vertically downward. Getting my point? So in that way, the answer should be C. Okay? Now, if a bar magnet is cut down into pieces, each and every part of the magnet will behave as a magnet but with lesser strength. This is what we discussed in the topic known as theory of magnetism. So here as well, north you can see at the left hand of the bar magnet, while south is at the right hand of the bar magnet. The bar magnet is broken into part X, Y, Z. So this is part X, this is part Y, this is part Z. One way to attempt MCQs is to check each and every option. If you are not sure about it, which one is correct. The other way, if you know the right answer. There are only two. And the third way, you know the wrong answers. So there are three ways to solve MCQs. One, you check out each and every option. Second, you know the correct answer. Third, you know the wrong answers. So this is how the correct answer will, always come on surface. Which diagram shows the poles in X, Y, Z. So here I know the correct answer. So how I know the correct answer? North is towards left. So no matter what happens, every part of the bar magnet or each and every broken piece of the bar magnet will be having north towards left. The south is towards right. Now, I'll see the options, which option is completely lying into this definition. So here, there are only, this cannot happen. There is no pole, there is no pole. And magnet cannot behave as a single pole. Okay? Monopole magnet does not exist. Magnet exists in dipole, two poles. And यहाँ पे तो pole है ही नहीं. So that cannot be correct. So north north no, south south no, कोई magnet नहीं है, pole नहीं है, no. North north no, south south no, north south wrong. North south, north south, north south. So you see that whatever we have discussed prior to the discussion of options, we have already found our answer. We were just looking where the answer is. So this is question 4. Now, an X of the metal rod attracts north pole of the compass needle. Okay, that means an X, if attracts the north pole of the compass needle, there must be south here. Okay, what does this show about the rod? It could be made up of copper, but not permanently magnetized. First and foremost thing, copper is not the part of the magnetic material family. So this is wrong. It could be made of copper. No. It could be made up of steel. Yes, steel is a magnetic material, so it can be attracted to the compass needle. Because compass needle की जो needle होती है, that is permanently magnetized, which is made up of steel. But is not permanently magnetized. Yes, देखिए, as we talk about iron, when a magnet is placed near the iron, is attracted to the magnet. Similarly, if a magnet is placed near the steel, steel will also be attracted to the magnet. Okay, but the property of iron is that iron becomes temporarily magnetized. But if you have permanently magnetized steel, it will retain its magnetism for longer duration of time. But if both iron and steel are not permanently magnetized, they will be attracting as the iron is, used to attract by bar magnet. Okay. So it could be made up of steel. Yes, it's a magnetic material. but not permanently magnetized. Yes, we can say that it's not permanently magnetized because here only attraction is being talked about. If you talk about permanent magnet, you have to include the discussion of repulsion as well. It could be made up of steel with north pole at X. No, we say that and X is having south pole. So that is why we say that option D is also wrong. In that way, C is our correct answer. Question number 6. Which of the following will prove that metal bar is a permanent magnetic material? For the identification of pole of a magnet or any magnet. Not attraction helps you because attraction is also happening in iron, unmagnetized iron. Attraction is also happening in unmagnetized or permanent, not permanently magnetized steel. But if a material is permanently magnetized, repulsion will take place. Okay. So here it attracts another magnet, does not explain. It attracts both ends of the compass needle, does not explain. It conducts electricity. No, we are talking about magnetism. It repels another magnet. Yes, D. Question number 7. Which of the following is an example of induced magnetism? What is meant by induced magnetism? Without making physical contact with the help of magnetic field, poles are generated in a magnetic material. So keeping this definition in mind, let's move ahead. Compass needle pointing north. Compass is also, already a magnetic material or a permanently magnetized material. Okay. Pointing north, he's talking about the north of the earth. So that is also a permanent magnet. So here, nobody is infusing or inducing poles on each other. They already have their poles. So that not a correct answer. North pole attracting iron filings. So if north of the magnet is placed near the pieces of iron, so what will happen? This north will generate south here and north here. South here and north here. And when the poles are generated without making physical contact, then attraction will occur. Okay. So if a north is attracting iron filings, first north created or north induced poles in the iron filings. After that, attraction is happening. So in my opinion, B is the correct answer. But as I told you, always discuss the other remaining options as well. This gives you a clear idea that if you're going right or wrong. Sometimes you see option B seems to be correct, but when you read option C or option D, this makes more sense. North pole of the a north pole repelling a north pole. That means north pole repelling a north pole. The other part is also a magnetized material because repulsion is occurring. So north pole did not create north pole in other magnet. Getting my point? Induction creates or redistributes the poles. Okay, just like here, north distributed south and north in the iron filing. So wrong. Coil of a motor turning in a magnetic field. Coil of a motor turning in a magnetic field. Here we are not talking about induced magnetism because motor talks about electromagnet. And in electromagnet, the wire in which the current is flowing is a magnetic material, is not a magnetic material, it's copper. So we'll talk about this concept further in the last or the second chapter of magnetism. Question number 8. A rod XY placed near the magnet. The end X is attracted when it is placed near the North Pole. So end X is attracted when it is placed near the North Pole. That means end X is making South Pole here, while North Pole should be at this part. And also when it is placed near the South Pole. Similarly, when end X is placed near the South Pole, it is also attracting. That means here should be North and South. So you can see and X is sometime behaving as a South Pole and X is sometime behaving as a North Pole. यहाँ पे एक ही बात आती है, किसका दीनमान नहीं होता, आयरन का. So that rod XY should be made up of iron because it becomes a magnet. I mean, according to the magnet, according to the permanent magnet. So when permanent magnet wants it that to create a south pole at end X, it will create a south pole at end X. If permanent magnet wants to create a north pole at end X, it will make a north pole at end X. So one of the identification of temporary magnet is that it does not have fixed position of its poles. Sometime it is behaving south at X, sometime it is behaving north at X. So it is made up of iron. Now, how does Ny behave when it is placed in turn of the two poles of the magnet? Since it is iron, so when Ny is placed here, let's say when here is Ny and Y is here and X is here, so north will be there, south will be there. Similarly, if Y is there and X is there, so south will be here, north will be here because this magnet is in charge. This magnet is, this magnet decides where to place north and south. Getting my point? So in both cases, whichever side you place near the magnet, iron hai, it will always be attracted. So in that case, attraction. So we have found out the correct answer in the first place. So A is the correct answer for question number 8. Now let's talk about question number 9. Steel ball on a horizontal wooden table rolls near the north pole of a bar magnet lying on the table. He just said steel ball. He did not said that steel ball has been magnetized. So I'll consider steel ball as a magnetic material, not as a permanent magnetic material. Getting my point? So whenever a magnetic material comes near a magnet, what happens? Attraction. Okay. Now, in which diagram shows most likely the path of the ball as seen from the above of the table? So here I told you steel ball is a magnetic material, but there is nothing being discussed in the question that steel ball has been permanently magnetized. So I'll not consider it as a permanent magnet. Okay. And if it is not a permanent magnet, it will not show any repulsion. So in that way, you can see steel ball is moving away from the magnet, which shows repulsion, which is not correct here. Attraction, because it is coming near the magnet. So in my opinion, answer is B. But let's discuss the other options as well. Here, steel ball is moving straight. That means that is an absurd thing, that a steel ball does not have any exposure or of the magnetic field of a bar magnet. ऐसा तो नहीं हो सकता. So wrong. Similarly, here steel ball moved and then stopped. This does not make any sense. If a steel ball have any influence of that bar magnet, it should be attracted. So here, why it is stopping, that does not make any sense. In that way, B is the correct answer. Now, last MCQ. An electromagnet is used to separate magnetic material from the non-magnetic material. He's talking about electromagnet, which is a temporary magnet. So how do we separate electromagnet? How do we separate magnetic material from non-magnetic material using electromagnet? Simply, if we place a magnet near a magnetic material gets attracted. But if we place a magnet near a non-magnetic material, it does not have any reaction on it. Okay. So let's see if we have a dish full of copper and iron paper clips. And if we move the electromagnet near it, what happens? Only iron, which is a magnetic material, get attracted to the electromagnet, not the copper paper clips. So why steel is unsuitable as the core of an electromagnet? As I told you earlier, when we talk about electromagnet, we are talking about temporary magnet. And steel does not make temporary magnet. So it's a good conductor of electricity. We are not talking about electricity here. We are talking about magnetism. It forms permanent magnet. Yeah, that is why it is not the part of the electromagnet, because electromagnet is a temporary magnet. It has high density, doesn't matter, and it has high thermal capacity. We are not discussing heat or thermal physics here. So in that way, B is the correct answer. So these were the explanation of the MCQs we had. Okay, beta? Now, let's talk about descriptive questions. So Figure 1.1 shows a magnet and two compasses and two nails. On figure 1.1, draw an arrow in each of the compass to show the direction of the magnetic field at the two positions. In that case, I'll be drawing the magnetic pattern of a bar magnet. So here, the magnetic pattern of the bar magnet will move from north to south. And here, straight. So the direction is here is towards left and from north to south. In that way, we should be having the answer as like this. Okay. Some student made a mistake and draw the compass position like this because it does not make any sense if the compass is going like this. This is not the pattern of the magnetic field of a bar magnet. It should start from north and end at south. In that way, you should be drawing a horizontal position of a magnetic compass because it's basically the middle of the magnet. Getting my point? So here you got 1 mark for this and 1 mark for this. That means here you got 2 marks. Getting my point? Now, the magnet causes nail to become magnetized by induction without making physical contact. Both ends of each of the nail become magnetic poles. Okay, both ends of the nail become magnetic poles. On figure 1.1, mark north or a south pole on each of the two nails. Okay, we need to draw at least one north or south, or you can draw both. So here, what happens? Permanent magnet will generate south here, south and north. Now you can say this north or this north generates south here, south, north. And I told you earlier, whenever you talk about if a bar magnet is magnetizing any magnetic material, the orientation of the poles will be same. Like if the north of the bar magnet is towards right, the north of the induced magnet will also be towards the right. So here you get 1 mark for this, 1 mark for this. So that is how you get 2 marks. This is question number 1 of descriptive questions. Now, question number 2 of descriptive question. Option A, B, C, D are aluminum bar, unmagnetized iron bar, 2 bar magnets. Okay, we are given with 3 materials: aluminum bar, unmagnetized iron bar, and bar magnets. Okay, the tests are performed to find out which bar is which. I mean, कौन सी बार यहाँ पे कौन सी बार है, if it is aluminum, unmagnetized iron, or a bar magnet. Let's find out. Each row in figure 2.1 shows what happens when 2 of the bars are placed end to end. Now, one more important thing. Most of the students did the mistake here and they did not read this list properly. And they wrote according to what they have been having their minds. I mean, कुछ बच्चों ने यहाँ पे लिख दिया कि permanently magnetized material. It is not written anywhere. Getting my point? So if examiner gives you a list of material, you need to use that list. Now, A and B repel कर रहे हैं, तो repulsion 2 bar magnets में ही हो सकती है, 2 permanent magnets में ही हो सकती है. So in that way, bar A and bar B is bar magnet. तो यहाँ पे I'm writing the short form bar magnet, bar magnet. As A is bar magnet, B is bar magnet, let's talk about here attraction. Okay, so if it was a bar magnet, यहाँ पे भी repulsion नहीं होती, yeah, as you can say attraction होती, but attraction एक और चीज में भी हो सकती है, unmagnetized iron में. तो C is unmagnetized iron. UMI unmagnetized iron. And we are left with D. D, we are having no effect. That means it's a non-magnetic material. And from our list, it should be aluminum. So that is how we identified each and every bar's material. And most of the students, I don't know why, did not see this question and they left this question. Why? I mean, why did you not read the question properly? So that is a mistake. Which material makes permanent magnet? So here the students are writing bar magnet. He's asking about you. What is the material? You are writing bar magnet. That is not a correct answer. You need to write either iron or steel. So permanent magnet is made by steel. That way, 1 mark, 1 mark, 1 mark, 1 mark, 1 mark, and that is how you get 5 marks. So that was question number 2 of descriptive questions. Now, figure 3.1 shows the view from above of the sheet of the cardboard on the top of the bar magnet. The dotted line shows the outline of a bar magnet. Okay. That means we don't have to write down, place a bar magnet on an A4 size paper and draw an outline around it. That step should be omitted because examiner already told you that the dotted line shows the outline of a bar magnet. Now, one thing which I've seen in almost 30% of the papers is some students explain this concept using iron filings. Why, beta? When I was teaching you this concept, I told you in bold letters whenever examiner asks you to draw the magnetic field pattern of a bar magnet, don't use the concept of iron filings. Always use the concept of magnetic compass. And I have explained you experimentally as well as theoretically this part of the question. So that was a bit, I would say, not easy for me to see that students have written down what I have told them not to write down. That will not give you any mark. Okay? So only whenever you are being asked to how to plot the magnetic field line of a bar magnet, you need to work with the compass pattern because iron filing gives you the shape. Iron filing does not even tell you where is north and south pole. Getting my point? So now describe how the pattern of the magnet around the bar magnet can be shown experimentally. Always go with compass process. If you wish, you may draw the diagram on figure 3.1 as well as write down on the lines below. So I'll always say that whenever you are given space to draw the diagram, you should draw the diagram because you cannot get an idea if there are marks for that diagram or not. Getting my point? So we don't have to write down the first step, place bar magnet on a piece of paper and draw an outline around it as it is already explained in the question. Now, what we do, place bar magnet near pole, sorry, place magnetic compass. Sorry. That is step 1. Okay. And here you can write down any pole. Okay. Let's say I'm drawing a north pole here and I'm drawing the south pole here. So if I place a bar magnet here, sorry, magnetic compass here, so the direction of the magnetic compass should be like this. Remember that the arrowhead on the magnetic compass represents north. Okay. So here I see, I mean, what I did, place the magnetic compass near north pole of a bar magnet and mark a dot where north of compass aligns. So this is I also showed in the diagram like this. Okay. Now replace the compass. This gives you 1 mark. so that south of compass aligns with dot, and remark another dot where north of compass aligns. This will give you mark number 2. Okay, so I can show that in the diagram as well, like this. Okay, now join dots to draw magnetic field lines. And this will give you mark number 3. So as you can show, already you have showed the process. You can show the dots here, and you can show how you join these dots to draw magnetic field line like this. You don't have to draw the direction because it's not being asked in the question that you need to draw the direction of the magnetic field as well. Okay, if you draw the direction, that is, I mean, a privilege for examiner or for you. So that is how. So this will give you mark number 4. And that is how you are having the 4 marks. Okay, beta? This is how the experimental way of plotting the field lines of a magnetic compass should be done. Don't go with iron filings concept. Again, telling you. Finally, what would you do? How would you identify the north pole of a magnet? Well, I'm sure why the students are making mistake again and again. I have already given this type of question in homework as well. And in test as well, still some of the students are using the concept of attraction. But attraction also happens in iron, which does not have the fixed position of the pole. So why should we use that, concept of attraction to identify the poles? Always go with repulsion. Okay, so there are multiple ways to explain this part. One of them, on the most popular one, is place it near the north pole of known magnet. If repulsion occurs, it's north. Simple as that. Don't go with the concept that place it near the south of the magnet. If attraction occurs, it's not pole. No, whenever you want to identify, go with the repulsion concept. Okay, beta? The other way you can write down the answer is by using magnetic compass. And you can write it down as place magnet near the magnetic compass. If the tail of the compass or the south of the compass is coming towards the end of the pole, that is the north. Okay. So you can also write the answer like this. So this will give you 1 mark, and that is how 1 mark for that part. Now we are left with last question, I believe. Yes. And in that last question, question number 4, 2 magnets are laid on a bench. And A of an identified rod is held in turn above one end of each magnet with the result shown. So here what is happening? And A is attracted. So that means the magnetic compass generated north here. That is why attraction is happening. Similarly, and A is attracted again. That means north has generated south here. So sometime and A is here making a north pole, sometime making a south pole. That means koi di niman nahi hota, it's iron. Which material it is made from? Iron. This will give you 1 mark. Now, state what happens. State what, if anything, happens when end A is held over one end of unmagnetized iron bar. That means This is already an iron. We have already told you that this is an iron. So this is only behaves as a magnet when it is near the magnet. So here they are saying that if and A, which is an iron, and it only behaves as a magnet if it is placed near the magnet. But if that iron bar is not near the magnet, it will not behave as a magnet. So unmagnetized iron bar, still it will not behave as a magnet, and A belongs to unmagnetized iron bar. That means you are placing two unmagnetized iron bar close to each other and nothing will happen. Similarly, if and A is placed near the plastic is a non-magnetic material, no effect. And that is how you will be awarded with 1 mark for each. Okay. Now, figure 4.2 shows 4 identical plotting compasses placed around a bar magnet where the magnetic field of the surrounding can be ignored. Matlab, you can ignore the magnetic field of the surrounding. You just only need to focus on these 3 positions. The pointer has always been drawn on, the pointer has only been drawn on one of the compass. So here you can see that examiner has already drawn the pointer. And we have to draw the pointer in these 3 places. On figure 4.2, draw the pointers on other 3 plotting compasses to indicate the direction of the magnetic field of a bar magnet in those 3 places. Now, as I told you earlier, the pointy part is north and this one is south. So again, we have to recall the pattern of a magnetic field of a bar magnet. So we can draw the pattern like this, like this, like this, like this, through the dots. Otherwise, we have already had the discussion that how the complete magnetic field pattern of a bar magnet look like. So according to that concept, the field line is outward from the north, inward for the south. That way you can draw the arrows like this. Through the dots. And this will give you 1 mark each for the position 1, 2, 3. And that is how you are having 3 marks. And this is the whole walkthrough or solution of first test we have already conducted. So I hope you have your concepts clear. If you have any question, if you have any ambiguity, if you have any query, it must have been resolved. If still you are having a question, so you can, message me on WhatsApp and we can discuss that part. Okay, beta? So we'll not be discussing that, question or the solution of the paper in the regular class, which will be occurring tomorrow, 9 to 10 p.m. PST. Okay, beta? So have a very good care of you. Keep me in your prayers and Allah.